Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
So, first you want to know how to determine concavity. Concave up, there are three ways you can tell if something is concave up. If you are looking just at F, when it is up like a cup, it is concave up. When you are looking at F prime, when it is increasing, it is concave up. And when you are looking at F double prime, when it is greater than 0, it is concave up. When you are looking at concave down, F is concave down when it is down like a frown. F prime, when it is decreasing, is concave down, and F double prime, when it is less than 0, is concave down. So, in this graph on the bottom, where y equals f prime of x, the slope of the left of the x-axis is decreasing, and because you're looking at f prime, it would be concave down. And when you are looking at the right of the x-axis, it is increasing, and it is f prime, so it is concave.
Question. Number 84 is calculator active, so just keep that in mind. For x is between negative 1.5 and 5, let f be a function with the first derivative given by f prime of x equals e to the power x fourth minus 2x squared plus 1 minus 2. Which of the following are all intervals on which the graph of f is concave down? So first you're going to want to note for all values y equals f prime of x, to be concave down, it has to be decreasing. Then you're going to want to pull out your graphing calculator, and you're going to want to plug the f prime of x function into y1. This is the graph that is going to show up if you put your intervals from negative 1.5 to 1.5, so you are only looking at what you need to look at and you don't get distracted by what the others things are going on in your graph. And then you are going to want to look at where it is decreasing, because we are looking at f prime and it is decreasing in 2 spots. So because it is decreasing in 2 spots, you can take away A, B, and E right off the bat. And for f to be concave down, f double prime has to be less than 0, and f prime has to be decreasing. So on the graph shown again at the bottom left, you can see that there's 2 decreasing places. And clearly shown from this graph, it's from negative 1.5 to negative 1 and 0 to 1. But if that wasn't so clear, you can find the relative max and relative min to find the x locations. So in this example, answered letter D is your answer.
The FRQ for this example. The figure above shows the graph of f prime given by f prime of x equals ln x squared plus 1 times sine of x squared on the closed interval 0 to 3. The function f is twice differentiable with f of 0 equaling 3. Part A. Use the graph of f prime to determine whether the graph of f concaves up or concaves down on the interval 0 to 1. Justify your answer. So first, note when determining concavity, f prime of x equals y has to be increasing, would make it concave up, and decreasing equals concave down. So just keep that in mind while answering the problem. And because you're only going to 0 to 1 on this graph, you want to just focus on that region because there is a lot more given to you than what you need. So here's where you need to be focusing from 0 to 1. And because f prime of x equals to y values, it is increasing, so this graph is concave up. F is concave up on the interval 0 to 1 because f prime of x is increasing on the interval 0 to 1. So in this problem, you need to make sure you include the subject and you need to clearly state what you are supposed to be stating. So in this, you can say concave up. And you know this because you are given the graph of f prime.